Hey guys, welcome back to another video on the channel. In the previous video, we discussed self-consistency prompting, where the model generates multiple reasoning paths and selects the answer that appears most frequently. Despite this approach working pretty well, it had an important limitation. As we can see in this example, even though the third reasoning path makes a mistake early on, the model continues generating the entire reasoning chain until the final answer. As a result, computational resources and tokens are spent on reasoning paths that may already be heading in the wrong direction. Tree of Thoughts was introduced to address this limitation. Instead of generating complete reasoning chains and only making a decision at the end, Tree of Thoughts evaluates intermediate reasoning steps as they are generated. It keeps exploring promising paths while pruning weaker ones, making the reasoning process more efficient and deliberate. You can think of Tree of Thoughts as moving from a simple reasoning search-based reasoning. Rather than following one path or voting only on final answer, the model explores, evaluates, and searches through multiple possible paths before deciding on a solution. To understand the core idea behind Tree of Thoughts, let's look at one of the most famous prompts from the paper. Imagine three different experts trying to solve the same problem together. Each expert writes down one step of their reasoning and shares it with the group. After seeing everyone's thoughts, they continue to the next step. If an expert realizes that the reasoning is incorrect at any point, they stop contributing, while the remaining experts continue exploring more promising directions. This simple prompt captures the essence of Tree of Thoughts, generating multiple reasoning paths, evaluating them along the way, and focusing only on the path that appears most promising. So now that we have understood Tree of Thoughts clearly, we will look at the pipeline it follows. So firstly, just like chain of thought, it breaks down the problem into simpler steps. Secondly, it generates multiple candidate thoughts from the current state. These are basically the possible next reasoning steps. So there are two approaches by which we can do so. So first is sampling and second is proposing. So in sampling, we generate several thoughts independently, which is very useful for creative tasks. And second, we are proposing where we generate a list of different candidate thoughts in one go. So these are basically useful for constraint heavy tasks or equations where we only have a set of outputs. So generating all of them is very beneficial to go further on. Now, for evaluation of each of these thoughts, there are two methods suggested in the paper. First is value-based, that is scoring on each thought or state on how good it is. The better it is, the higher score it gets. And second is vote-based. So basically, the LLM votes on the best possible answer or the best set of answers. So now, how do we perform search on these thoughts or paths that we have generated? So there are two primary approaches, one of them being breadth first search and the second being depth first search. So in breadth first search, what we basically do is we keep the top the most promising thoughts or states at every step and move forward and expanding each of them only. So the top B could be either the highest scored states or the ones with the maximum amount of votes. And secondly, it's DFS. In DFS, basically, we explore the most promising path that is either the most voted or the most top ranked with the one with the highest score path. And if it looks impossible at any step, we backtrack and try another, the second best path. And after all of this process, we finally arrive at a solution which looks the most promising among all of them, the entire solution space. So why does tree of thought approach works pretty well? The first reason is that we are taking into account multiple paths. Just like self-consistency, we are taking into account multiple paths which decrease the chances of us to reach at a wrong answer. Secondly, we are using early pruning. So basically, if the model sees a path which is going in a direction where it's impossible to get the correct answer, we stop it then and there only, which avoids the loss of important resources and tokens. And thirdly, it's backtracking and looking ahead. So basically, if the model sees in the path that it's not going to lead to the correct answer, we can backtrack and look at the second best option. And fourthly, DFS and BFS are very systematic based searches. So most of the time we will land at a solution which is the highly promising one. So here is the basic comparison between chain of thought, self-consistency, and tree of thought. So in chain of thought, we have a problem. We break it down into simple steps and generate reasoning for each of the step and finally land at a final answer. Is in self-consistency, we have a problem. We generate multiple reasoning paths, trying different approaches. We get multiple answers from this, and then we perform a majority voting on these answers to finally get to a final answer. And the third approach is tree of thoughts that, as we discussed, we have a problem. We generate multiple thoughts or candidate states. We evaluate each one of these intermediate states and we keep the top best branches. And via BFS or DFS search, we either expand or backtrack and then finally arrive at a final answer. So the results observed by the model were pretty impressive. So as you could see that tree of thoughts was able to perform better than chain of thought and chain of thought with self-consistency. Here the B which you could see basically means B equal to 1 basically means that we only consider the most optimal solution for breadth first search and B equal to 5 means that we consider the top 5 best solutions. So you could see that not only did self-consistency perform pretty well across mathematical reasoning, but it also performed effectively better at creative writing and crossword-solving tasks, which was seen as a weakness of chain of thought and self-consistency. That is, they performed pretty well in those tasks like maths or logical reasoning, but they struggled a lot in creative writing, which was not the case for tree of thoughts. So the primary reason for this is, as you could guess, like while in sampling different approaches, we for creative writing tasks, we use independent thoughts, which help in boosting the creativity. So even though tree of thoughts approach works pretty well, it has a few limitations. Firstly, its computational cost is pretty high. As you could see, we are exploring multiple paths, going along different directions. So the cost for all of this is pretty high. Secondly, it takes a lot of time to actually think about each of the step, then move forward or expand or backtrack. So it's not very beneficial for real-time applications. Thirdly, it requires a lot of careful tuning. Like you need to ensure that from this particular path, we are definitely not going to get a particular answer and then only prove it. Or if we have a lot of branches, then it becomes very difficult. And also, some of the paths could become very redundant, thus costing a waste of tokens. So that brings us to the end of Tree of Thoughts. In this video, we learned how Tree of Thoughts extends the ideas introduced by Chain of Thought and self-consistency prompting. Instead of relying on a single reasoning path or voting only on final answers, Tree of Thoughts evaluates intermediate reasoning steps, exploring multiple possibilities, and uses search strategies to focus on most promising solution. We also look at how complex this approach work and how some of its limitations. So that is going to be it from my side. If you guys enjoyed the video, make sure to like, comment and subscribe and let me know how I could improve my videos in the future. Thank you guys.